Welcome to my Gcard video about traveling salesman problem. In this one, I'm gonna introduce about the problems why we call it is traveling salesman, and I will run the code for this one. In the background, the traveling salesman problems is the problem that we try to find the minimum cost path that visit every node in a graph. For more specific, when um, we try to give a list of cities and the distances between each pair of city, and then what we want to find is the shortest possible route that visits every city exactly once and return to the origin city. Like we uh, like for in the graph we have the uh, vertices, and then we have the way, which is the distance between each uh, vertice. So the problem is we try to find the shortest uh, the shortest path that visit every node in the graph exactly once and return to the first one. To make it clear, like in each graph we have New York City, Phoenix, Los Angeles, Chicago, and Houston. So and then uh, between one city and the rest, like New York to Los Angeles or New York to Phoenix, we also have the distance between each city. And our problem is try to find the shortest path that's travel from one city to the rest, and when we sum the distance, uh, we will have like the shortest one. And the first approach, which is the brute force solution, this is the simplest solution. That's it. We just try to find all the possible permutation, and then we sum uh, the way together and try to find the smallest one. So in the roof, you can see the code in here. I, I, I wrote the for the brute force solution, uh, the data structure I use, which is the array list. Uh, I will put every city into the list, and then I use the iterative uh, uh, to find all the possible permutation, and for each permutation I will have like the cost, which is the route from one city to the rest of the city in the graph. With the data structure array list I can do that, and then finally I can um, find the minimum one, which is the possible solution for us in the traveling salesman. The problem in here, that's because for the root force solution we can only apply for a small number of city or vertices, because if you for the big O notation, this solution, which is the O2 to the n, is very big and very important. It's impossible for a large number of vertices. Um, that's why this is the simplest one, and this is very impossible when we have like 50 city or larger number of city. And then uh, to uh, counter that problem, the second approach, which is the pre-minimum spending tree. This one we will use the pre-minimum spending tree algorithm to get the minimum spending tree, and then we perform the depth first traversal of that tree to visit the city in the order we encounter. In here we use the pre-order depth first search. So for the second approach, we can deal with a large number of city or vertices. Uh, the first step, we can use the minimum spending tree to get the shortest distance between one city to the rest of the city. Uh, Once we can, and then we put it into kind of like the list for the depth first traversal later, because in the second step we can perform the depth first traversal to go into the next node to find the shortest path between one node to the rest of the city. And then this is the code I wrote for the pre-minimum spend tree. It is divided into two sections, which is if the first step is the minimum spending tree, we can use the hash map to find to filter uh, which city uh, have the shortest distance between itself and to the point we consider. We use the data structure, which is the hash map, and while we finish that structure, we will perform the next step, which is the depth first traversal. The depth first traversal, we try like from the origin point, we can perform like the path of and the algorithm to perform the path is based on the shortest distance from one point to the rest point. And then when we perform the depth first traversal, we can uh, find the point for us to perform the minimum spending tree in the next step until we finish all the step and come back to the origin city. Okay, let me run the code I wrote. Okay, in order to run the code, this is the code I will try to run. As you can see, for this section, this is from the permutation solution, and which is the brute force solution, and this one we use um, prim the minimum spending tree solution. And next step, we can reset it, and I can for the first step I can reset it. I do it for this one. Something little bit make me confused. maybe maybe this one is perform the minimum spanning tree, and this is perform the permutation. Yeah, it's my fault. It is a little bit I'm wrong in the first one. Okay, this is the algorithm simulation. Okay, you can check out the code I wrote on the GitHub. Okay, thank you so much for listening.